All right, the last thing I want to talk to you guys about in this section is how to change from a exponential model with any base to a base of e. So we are going to use this statement here. So let's say your model is y equals a times b to the x. So your exponential piece is that b to the x part there, and you're multiplying by a. Then you can change it to a base of e by making this change right here. So the a stays the same, but what happens is that b is going to become e to the natural log of b. And it uses the inverse properties there. So remember, e and natural log cancel each other out. So basically, e to the natural log of b is just b. It's the same thing. It's just that we were able to use that exponential base instead. And that can be more helpful because we do have that basic setup for our growth and decay models with our base being e there. So this, again, it can be helpful to sometimes convert to that base e. It's one that we use often. So it's nice to be able to go back and forth if we need to. So we've seen that the function g of x equals 2.634 times 1.016 to the x is one of our models for world population in billions, x years after 1949. And we want to just rewrite this model using base e. So what's going to happen is that initial number stays the same, right? So notice the a doesn't change what's on the outside. This is the part that changes here. So what we're going to use instead is we use base e, and then we take the natural log of this. And then multiply that by x. Okay. Now, this is, one of the more accurate answers here, but you actually can simplify this a little bit. We don't want to cancel the e out here. I just want to work with this part right here. So if you want, you could use your calculator. Let's see what we get. Natural log of 1.016. So we get about 0.01587333492. Now I would use more decimal places here. So my thinking is I would probably write this as 0.015873. Going out 6 decimal places, but your book does only use 3 decimal places. So they write this as about 0.016 instead. So you can change that model over. You're just going to make sure you replace the e and then take the natural log of this value. Again, our goal here is to get that base e. So you don't want to cancel your e and your log out in this particular case. You're just going to use your calculator to find an approximation here. And now you have your model in terms of e. So you can see that it sort of mirrors that exponential growth model here. It is a growth model because our k value is positive. So you are expecting growth in this case. So let's see. So our k is 0.016. Exponential growth model. And remember, this is your growth rate. And the growth rate is always in that decimal form. So if you want to get it in your percent form, you would move that decimal point 2 spots to the right and use 1.6%. So that growth rate here is 1.6% for this exponential in this case. Now, one thing to note here, I'm just kind of reading from your book for a second, is that the actual growth rate, at least right now at the date of publication of the text, is only 1.1%, not 1.6%. So you do want to be a little careful here. Remember, when this model was created, we only used, let's see, 1, 2, 3, 4, 5, 6. I think we used, 6 data points, not too many data points. So if you actually look at more data, the current growth, at least at the time of publication, growth rate is only 1.1%. So our model is 1.6%, which is a bit high. So realistically, this would end up overestimating things in the long run. So that's why it's important to really try to create the best model you can with the most data and the most accurate exponential or linear, logarithmic, whatever model that you're using.